Okay, between video segments I did check, and that is the centroid of an individual section times the length of that section, not the total length. The centroid of an individual section here, the centroid of an area, times that individual area. We'll see an example of it coming up. Okay, so here is a good one. Show that the surface area is 4 pi r squared and its volume is 4/3 pi r cubed. And we can just go through this real easy. It's going to be the length of the red zone there is pi r, right? Oops, I don't want the laser pointer. Although that's kind of a cool thing to have around. I wanted the pen. So we have pi r is the length of that red line times the centroid, 2r over pi, times, let's see, length, and I haven't got my angle yet, which is 2 pi. So some of the pi's cancel out. We're going to get a 4r, equals 4 pi r squared. Now the area here of the orange is going to equal 1/2 pi r squared because it's half of a circle. It's not a full circle. The centroid, let's see, area here, centroid, 4r over 3 pi. Area, location, distance of the centroid, and finally the angle, 2 pi. We're going to go through a full revolution. So, like before, we have some factors that cancel. Volume. What did I say? This is surface area. Scratch this. Volume equals the area of the orange, distance of the centroid, times the angle. So we have, scratch that, that was started to be area, volume equals 4 over 3. It's the only numbers that are left. Only 1 pi, pi in the numerator, and r squared times r cubed. So using these theorems, we find the surface area and the volume of a sphere. Okay, and the book goes through the same idea. Now, this is a composite. This is how we handle composites. Find the surface area and the volume. So the first thing we want to do is, well, we identify the composites. Let's go to the next slide. I think, well, we have for surface area. Here, this is better for surface area. 1, 2, 3, 4. The dots are the locations of the centroids. So that's 3.5 inches this way and 1.5 this way. So I'm just making a note where the centroids are. 3 inches this way and 2.5 up. There. 2.5 that way. This is 1 inch. 1. There we go. And this is 0. It's at level. Although here's the, that's how far up it is in the z-axis direction. In the r direction, the locations are already marked. So let's go take a look at it. Surface area, 2 pi, individual individual r, individual l, 2 pi. There's the 2 pi. 2.5 times 2. Well, there's 2.5 here. That's the r. And then the l, it's not 2. Let's go take a look. Two pi r. Okay, there's r. So, 2.5. Yes, r times 2 inches. How long is the side? So the radius, length of the side. Radius, this is the slanted. That's the angular piece right there. Radius 3 inches. This is the back side. This one here is the front side, back side, slanted piece, bottom. Crunch the numbers, get an answer. Okay, now the area, let's go back. The area equals, well, that's 1/2 times 1 plus 1, 1/2 inch squared. And the have to add this, which is 2 by 1 plus 2 equals 2.5 inches squared. Okay. The centroid, now we have two composite areas. So the centroid of this is going to be at 3 inches and at 3 inches. I realized after I got done doing all this stuff, I don't need to know. They don't ask me. I don't need to know where the centroid is vertically. I just need to know horizontally where the centroid is. So for the square section, it's right there. For the triangle, it is 2/3 plus 2.5, which would be what? Get some extension lines going. Not supposed to do it this way, but we'll break a rule here. So this distance is going to be 2.5 inches plus 2/3. 2 and 3/6 plus 4/6 equals 7 1/6, or 3 1/6, excuse me. 3 plus 4 is 7. 3 1/6. Point, what is 1/6? It's 1 6 6 repeating. 3.1666 and so on to infinity and beyond. Okay, now we got that. That's the centroid of the triangle. Now we can add those up individually. So here's our, there it is. There's the distance there. This is the diagram that goes with it. 2 pi times the centroid. Oh, this is the surface area. They just What did they do? They did the calculation twice. Did they do the volume? There's the volume calculation right down at the bottom. 2 pi times that 3.1667 inches times the area. So the centroid times the area of the triangle. And now we have the centroid times the area of the square. Just add them up and we get total volume and total area. Okay, now we're going to move on to pressure and talk about fluid pressure, but I'm going to stop the video before moving on to that.